So, I love differential equations. Okay, so let's start with some linear first order, ODEs. Okay, so linear, right? So actually, let's just start with ODEs. Ordinary differential equation. We're only dealing with x's and y's here, or just two variables. First order, well, it basically means if we go here, we don't have a 2 over there. Okay, no 2. Okay, it's just like that. Okay, and then the linear means we don't have, y squared or y cubed, and we don't have like a y over here, for example. Okay, so I'm a little bit ill here. Right, so let's just get on with this. Let's try. Okay, get this. And what I want to do is I want to be able to solve this, because let's explain a little bit of the intuition here. If I have myself, right, if I take a derivative of a function, let's just call it f of x multiplied by y, okay? Well, what happens is I can use the product rule. Okay, you should know we can use the product rule here, and we can just get f dash of x y plus f of x dy over dx. Okay, and if I set this equal to some function, I don't know, g of x, we can already see, I mean, it looks kind of similar to what we're talking about here, right? Yeah. Oh wait, sorry, that should be the other way around. Yeah, there we go. Okay, it looks similar, right? We get this differential equation here in terms of this. So let's try and see if there is some kind of function that we can times called the integrating factor. Okay, some function, I'm just going to call this function capital F of x, okay, that I can just multiply my way through. That will enable me to be able to use the product rule, okay? And this is what we call here the integrating factor, okay? And it's just going to make being able to solve these linear differential equations a lot easier without having to use the product rule. So what we're going to do here is we're just simply going to write it down. F of x dy over dx plus p of x f of x y equals q of x f of x. Lovely. And now what we're doing here is we're going to try set up a little product rule. So what we want to do is we want to have dx, right? Brackets. And we want this part here to basically, remember what we did before? With the product rule, we get a part with a y and we get a part with a dy over dx. Basically what we want is we want, when we take our product rule, f of x, our integrating factor, multiplied by y, what we should be left is we should be left with these two parts, right? Okay, the right hand side stays the same, and then we simply just do it, right? We have f of x dy over dx, which is what we have over here, plus, and then f prime of x y equals q of x f of x. Lovely. Okay, and you might notice, right, over here, if I go ahead and just divide everything off by f of x, so dy over dx, all right, okay, the f of x cancels here, so we just have q of x. What you might notice is that if I highlight this maybe green, this p of x part here is exactly the same as this part here, because we have the exact same form. We got q of x, and then we got nothing next to the dy over dx. So this f prime of x over f of x should be p of x, okay? And that's how we set it up, right? We want it to be in this sort of form, okay? This is the form we're looking for. Right, because then we can simply just integrate and find y. Okay. Okay, lovely. So we find that p of x is equal to f prime of x over f of x. And again, we're solving for f of x. So what we're going to do here, it's kind of interesting, but we're actually going to integrate both sides. Okay, and you'll see in a minute why. Maybe you already see it. Because this little f prime of x over f of x is actually very familiar. And this is something that turns up a lot when you do the chain rule with ln of x. So if you've worked a lot with integrals, you might know that that is actually, that should just be an equals and otherwise a plus. This should be ln mod f of x. All right, we don't have to worry about plus c right now, okay, because we're kind of just doing an operation, we're not finding a solution or anything. And then we simply just go ahead and solve for f of x by raising it to the power of e. So we get e to the power of this integral, which is kind of weird. You know, you look at it and you're like, what? And there you go. Yeah, I mean, again, the reason we don't count anything here with the plus c is because when we integrate both sides, you would have a plus c as well, and then you'd have a plus c here, and those plus c's cancel out. So we don't really need to worry about plus c's, and those plus c's should be the same. Okay, so we just found our integrating factor. And this integrating factor is really going to help us solve the differential equation. Because if you go back to this line here, this is an important line, right? What we have here is we're saying that d over dx of f of x, y, equals q of x, f of x. But we know that f of x is now this. So we can say that d over dx, and then e to the integral p of x dx times y equals q of x, and q of x, e to the integral of p of x dx. And then we can integrate both sides here. Like so, with respect to dx. You can divide both sides by that. Lovely. And there you go. If you really want to, right here you have found a solution to the differential equation. This is an exact solution. It will give you the solution to the differential equation. Now, you don't need to memorize this. Really, I wouldn't do that. I would just memorize the integrating factor and then go ahead and just multiply by f of x everywhere. But if you want an exact solution to the problem, there it is. Right, there it is. You can do it there. Okay, you find what your p of x, you find a q of x, and then you put them into here. That's obviously assuming that you can actually integrate the function that you get over here. Assuming you can integrate p of x, and you can also integrate this concoction you get over here. Which hopefully you can. I mean, take a bit of work, but you probably could. And yeah, this is an exact solution. This will give you the solution to your differential equation, which is making the video short. I just wanted to give a little example here because this kind of stuff is difficult. So let's work with this. The first thing is we're going to get dy over dx on its own. So we get rid of the x's like so, just by dividing through. And we get to our next step of working out, which is dy over dx plus 2xy equals e to the negative x squared. Okay, now what we do? Well, we go back to our integrating factor. We want to find some integrating factor, that we times everywhere, that will allow us to integrate. And the way we find integrating factor is we look next to the y, and we're like, okay, so our integrating factor, I'm going to call this f of x, is equal to e to the integral of 2 to the x, oh, it's not to the x, but just 2x dx. And this should give us e, and then we can just integrate that, not too difficult to integrate. You just raise the power, divide by the new power to get x squared like so. Lovely. Times everything by that to get e to the x squared dy over dx plus 2x e to the x squared y equals, and then here we times by that. If you times by e to the, if you think about this, this is e to the x squared reciprocated because we got the negative. So we times by e to the x squared, just cancel and you just left with 1. So really we're just going to be left with 1 on this side. Lovely. Then we can go ahead and open our brackets. And we'll be left here with e to the x squared, right? Times by y, remember the y. Okay, people forget that. And you can see that using the, the product rule, it does integrate back into the, differentiate back into this. But we don't want to differentiate it back. We want to integrate both sides with respect to x, because we are in the x plane. Okay, we integrate one, you can just leave the one alone. And then we can just solve. If you integrate that, you're just left with x. Remember the plus c. People normally forget the plus c. Do you need to put the plus c in here? And then put y equals, and then divide by x. X, you can put over e to the x squared, but I'm just going to e to the negative x squared, just because it's nicer. And then plus, you can put c. I'm going to put k instead, just because it's neater. But you can put c if you want. And you're left with this. And that is your solution to the equation. If you want, you can write it like this, e to the negative x squared, and then put x plus k like so. And yeah, there we go. Yeah, that's pretty cool.